If you own a Windows 11 computer, especially one that isn't brand new, there's a decent chance something is running in the background right now, quietly consuming a chunk of your system's memory, without you ever having agreed to it, without any notification, without any obvious sign in your task manager pointing directly at the culprit. It's not malware, it's not a virus, it's a legitimate built-in Windows feature turned on by default on most machines running this operating system, and it's been specifically identified by technology researchers as a genuine contributor to slower performance, sluggish app launches, and unnecessarily high memory usage, particularly on lower-spec PCs that don't have much RAM to spare in the first place. This is the story of exactly what that feature is, why Microsoft built it the way they did, and the simple, safe steps you can take right now to shut it off and get some of your system's performance back. Let's start with understanding exactly what's actually happening here, because the feature in question has a fairly innocuous, almost bureaucratic name that doesn't immediately suggest anything is wrong: delivery optimization. Delivery optimization is a built-in Windows 11 service designed to make the process of downloading Windows updates and Microsoft Store apps more efficient across an entire network of devices, rather than each individual computer downloading everything separately and directly from Microsoft's own servers. The basic idea behind it is genuinely reasonable on paper. Instead of every single Windows PC on a shared network, say in an office building, a school, or even just a household with multiple computers, independently downloading the exact same update files directly from Microsoft, delivery optimization allows these devices to share pieces of those same update files with each other over the local network, and in some configurations, even over the broader internet with other Windows users entirely outside your own network. It works somewhat similarly to how peer-to-peer file sharing technology has functioned for decades, where instead of relying entirely on one central source for a file, multiple devices can share pieces of that file among themselves, reducing the overall burden on any single server, and in theory, speeding up the download process for everyone involved. In principle, this is a legitimately clever piece of engineering, and it's worth acknowledging why Microsoft built it in the first place, rather than assuming it exists purely as some kind of careless oversight. Microsoft manages Windows updates for well over 1 billion active devices worldwide. When a major update rolls out, the sheer volume of simultaneous download requests hitting Microsoft's servers can be staggering, and any technology that helps distribute that load more efficiently across a broader network, reducing strain on centralized infrastructure while potentially speeding up download times for the people actually receiving the update, represents a genuinely sensible piece of system design from an infrastructure perspective. The problem isn't that delivery optimization exists as a concept. The problem is how it's been implemented in practice, and specifically, how much system memory it's been observed consuming on a meaningful number of Windows 11 machines, often without users having any clear indication of exactly what's responsible for their PC feeling sluggish. According to reporting from Tom's Guide, this issue was specifically identified and documented by the publication's computing editor, who found that the delivery optimization service was quietly consuming a significant, disproportionate amount of system memory on Windows 11 machines, contributing directly to the kind of sluggish, slow performance that frustrates users without an obvious, easily identifiable explanation. This is precisely the kind of problem that's particularly damaging on lower-spec PCs, machines that don't have much RAM to begin with, since every gigabyte of memory consumed by a background service the average user has never heard of and never explicitly agreed to run represents that much less memory available for the actual applications, browser tabs, and programs someone is trying to use in the moment. On a machine with 16 or 32 gigabytes of RAM, a background service consuming an unexpected chunk of memory might go entirely unnoticed, simply absorbed into the machine's overall available headroom without producing any perceptible slowdown. On a machine with only 8 gigabytes of RAM, which remains an extremely common configuration for budget and mid-range laptops still being sold today, that same memory consumption can meaningfully impact how responsive the entire system feels during everyday use. This connects directly to something Microsoft itself has now openly acknowledged, which is genuinely important context for understanding why this specific issue matters as much as it does. In a public statement made in July of this year, Pavan Davuluri, president of Windows and Devices at Microsoft, directly admitted that Windows 11 idles at nearly 6 gigabytes of memory usage on systems equipped with only 8 gigabytes of total RAM. Read that number carefully, because it's a genuinely striking admission coming directly from Microsoft's own leadership. On an 8 gigabyte machine, simply having Windows 11 running, without opening a single additional application, without a web browser tab open, without anything the user has actually chosen to launch themselves, the operating system itself is consuming nearly 6 gigabytes of that total available memory. leaving barely 2 gigabytes of headroom for literally everything else the user actually wants to do with their computer. Microsoft has publicly committed to reducing this memory footprint through 2026 and into 2027, specifically citing ongoing work to optimize the WinUI framework that underlies much of the modern Windows interface, along with broader improvements to how the operating system allocates and manages memory across its various background processes and services. Delivery optimization represents one specific, concrete, and genuinely actionable piece of that much larger memory bloat problem that Microsoft has now publicly acknowledged exists. While Microsoft works on broader, more systemic fixes to Windows 11's overall memory footprint, a process that, by the company's own admission, will likely continue unfolding gradually over the following 1 to 2 years, individual users don't have to simply wait around for that slower, larger fix to arrive. Delivery optimization specifically can be disabled right now, today, by anyone comfortable navigating a few settings menus, and doing so can provide a genuine, immediate improvement in available system memory, particularly for anyone running an older or lower spec machine that's been feeling increasingly sluggish. There's a second related issue worth understanding as well, one that compounds this same broader memory concern and adds further weight to why checking your own system's background processes is genuinely worth the time it takes. Following a specific Windows 11 system update, identified by the update code KB507233, applying to both the 24.8.2 and 25H2 versions of Windows 11, reports emerged, initially flagged by the technology publication NeoWin, indicating that a separate background service called the Apex Deployment Service, sometimes abbreviated as AppXSS VC, began automatically starting up every time the affected machines booted. This particular service, responsible for handling the installation and management of modern Windows Store-style applications, has similarly been observed consuming notable amounts of CPU processing power, system memory, and disk activity, again without most users having any clear indication of what's actually responsible for their machine's degraded performance, or any prior notification that this specific background behavior had changed following a routine system update. It's worth pausing here to explain exactly why these kinds of background services can be so difficult for ordinary users to identify and diagnose on their own, because understanding this helps explain why a problem like this can persist, affecting potentially millions of machines, before anyone outside of dedicated technology researchers and enthusiast communities manages to properly identify and document the specific culprit. Windows, as an operating system, runs dozens, and in some configurations, hundreds of background processes and services simultaneously, most of which most users have never directly interacted with, configured, or even heard of by name. When a computer starts feeling sluggish, the average person's first instinct is rarely to open up Windows Task Manager and start scrolling through an unfamiliar list of processes with cryptic, technical-sounding names, trying to determine which specific one might be responsible for the slowdown. Even for people who do take that step, distinguishing between a genuinely essential system process that shouldn't be touched and a comparatively optional background service like delivery optimization that can be safely disabled without meaningfully impacting the core functionality of the operating system requires a level of technical knowledge that most everyday computer users simply haven't had reason to develop. This is precisely why a story like this one is genuinely worth understanding in some detail, rather than simply following a quick fix without any context. Understanding what delivery optimization actually does, why it exists, and what the practical trade-off involves in disabling it allows you to make a genuinely informed decision about whether turning it off makes sense for your own specific situation, rather than blindly following an instruction without understanding what you're actually changing about how your computer behaves. So let's walk through exactly what disabling delivery optimization actually involves, and what trade-off comes with making that change. According to the Tom's Guide reporting on this issue, turning off delivery optimization is described as safe to do, meaning it won't damage your system, won't prevent Windows updates from installing correctly, and won't cause any broader instability or functional problems with your operating system. The specific trade-off involved is straightforward and worth understanding clearly. Disabling delivery optimization means your computer will no longer participate in that peer-to-peer sharing. System for Windows updates and Microsoft Store app downloads, which means future updates and app installations will need to be downloaded entirely and directly from Microsoft's own servers, rather than potentially being sped up by pulling portions of those same files from other nearby devices on your network, or, depending on your specific configuration, from other Windows users elsewhere on the broader internet. In practical terms, this generally means Windows updates and Microsoft Store app downloads may take somewhat longer to complete after making this change, since your machine loses access to that supplementary distributed download source. For the average user, though, this trade-off tends to be genuinely worthwhile, particularly on a lower spec machine where the memory savings from disabling this background service can produce a noticeably more responsive experience during actual day-to-day computer use. Considerably more often than most people are sitting there actively waiting for a Windows update to finish downloading. To actually make this change on your own machine, the process involves navigating into Windows 11's Settings application, then finding your way to the Windows Update section specifically, where you'll find an option related to delivery optimization nested within the advanced update-related settings. From there, you can toggle off the option that allows downloads from other PCs, effectively disabling the peer-to-peer sharing component of the feature that's been identified as the primary source of its outsized memory consumption. This is a genuinely simple, reversible change, meaning if you ever decide you'd prefer to re-enable the feature, perhaps because you're specifically managing multiple Windows machines on the same local network and want to take advantage of the bandwidth savings, this feature is actually designed to provide. In that specific context, you can simply toggle the setting back on at any point without any lasting consequence from having disabled it temporarily. It's worth understanding a bit more about who this feature actually makes the most sense for, and correspondingly, who's most likely to benefit from disabling it, because delivery optimization isn't inherently a poorly designed feature for every single use case. In environments where genuinely large numbers of Windows machines exist, on the same local network, corporate offices, school computer labs, university dormitories with shared network infrastructure, delivery optimization can provide real, measurable bandwidth savings, since a single Windows Update file only needs to be downloaded directly from Microsoft's servers once or a handful of times before it can be efficiently redistributed to dozens or even hundreds of other machines on that same local network, considerably reducing the overall internet bandwidth consumed by the update process across the entire organization. For a typical home user, though, with perhaps one, two, or a small handful of personal devices, none of which are likely running Windows updates in perfect synchronization with each other at the exact same moment, the actual practical benefit of delivery optimization tends to be minimal at best, while the memory cost of running the service in the background remains essentially the same, regardless of whether it's actually providing any meaningful bandwidth savings in your specific situation. This distinction matters quite a bit for understanding why Microsoft's decision to enable this feature by default on essentially all Windows 11 installations, regardless of whether the specific machine sits within a large corporate network or exists as a single, isolated home computer, represents a genuinely reasonable point of criticism, a feature that provides real value in one specific context, large networks with many simultaneously updating Windows machines, but provides comparatively little value while still consuming meaningful system resources in a considerably more common context. Individual home users with just one or a few devices arguably shouldn't be enabled by default across every single installation, regardless of context. This is precisely the kind of design decision that technology researchers and reviewers have increasingly scrutinized as part of the broader conversation around Windows 11's memory efficiency and overall performance, particularly on the more budget-oriented, lower-spec hardware that a considerable portion of the actual Windows user base still relies on for their everyday computing needs. It's worth connecting this specific issue back to the broader pattern Microsoft itself has now publicly acknowledged, because understanding that broader context helps explain why individual fixes like disabling delivery optimization matter as part of a larger picture, rather than existing as an isolated one-off curiosity. Throughout 2026, Microsoft has taken several concrete, publicly documented steps specifically targeting Windows 11's memory efficiency problems more broadly. In April, the company released an update specifically targeting memory leaks within various system processes, including improvements to how the File Explorer process, Explorer XA, handles its own resource cleanup after windows are closed, ensuring the process properly terminates rather than continuing to consume CPU cycles and memory in the background after a user believes they've finished using it. Throughout the middle of the year, Microsoft's own Windows UI engineering team has been publicly discussing ongoing internal work to optimize the WinUI framework that underlies much of the modern Windows interface, specifically citing goals around reducing memory consumption and improving overall responsiveness, particularly benefiting users running lower spec hardware. And in a Windows Insider blog post published on July 31st of this year, Microsoft's own Windows team directly addressed a broader commitment made back in March regarding overall Windows quality, specifically highlighting continued improvements to memory efficiency, including the adoption of a more efficient memory allocator designed to reduce overhead across various apps and system components, alongside continued tuning of the WinUI framework, specifically so that applications built using it consume less memory by design, rather than requiring additional after-the-fact optimization work down the line. This pattern of ongoing, publicly documented work reveals something genuinely important about how to properly understand Windows 11's memory usage issues as a whole. This isn't a story about a single, isolated, hidden setting representing the entire problem, nor is it a story about Microsoft deliberately hiding a fix that makes things worse. An inaccurate framing that circulates occasionally online but doesn't hold up against the actual public record of what Microsoft has been doing throughout this year. It's a story about a legitimately complex, multi-layered performance problem, one that Microsoft has openly acknowledged exists, one the company is actively working to address through a combination of larger, systemic architectural changes that will take considerable additional time to fully roll out, alongside smaller, more immediately fixable individual issues, like delivery optimization's outsized memory footprint, that technology researchers and enthusiast communities have identified and documented well ahead of Microsoft's own broader fixes actually arriving for most users. Given that context, it's worth being genuinely direct and honest about what disabling delivery optimization or investigating and addressing the Apex deployment service issue following that specific KB50720033 update will and won't actually accomplish for your own computer's performance. These are genuinely useful, safe, and immediately actionable fixes, capable of freeing up a meaningful amount of system memory, particularly on machines with only 8 gigabytes of total RAM, where every additional gigabyte of available memory tends to produce a noticeably more responsive day-to-day computing experience. But these specific fixes address particular identified pieces of Windows 11's broader memory consumption pattern, not the entirety of the underlying issue that Microsoft's own leadership has publicly acknowledged exists across the operating system as a whole. If you're running a genuinely older, lower-spec machine, particularly one with only 8 gigabytes of RAM, disabling delivery optimization represents a meaningful, worthwhile improvement, but it likely won't entirely on its own transform a consistently sluggish, struggling machine into a genuinely fast, responsive one. It's one piece of a considerably larger performance puzzle, a puzzle that Microsoft itself has committed to continuing to address through 2026 and into 2027 through the kind of broader architectural changes to the WinUI framework and system memory allocation that individual users simply can't replicate on their own through a single settings toggle. For anyone specifically shopping for a new computer right now, rather than simply trying to optimize an existing machine they already own, this broader context carries a genuinely practical, forward-looking implication worth understanding as well. Technology publications covering this broader memory efficiency story have specifically recommended that buyers considering a new Windows 11 machine should strongly weigh opting for 16 gigabytes of RAM rather than settling for an entry-level 8 gigabyte configuration, given Microsoft's own direct admission that Windows 11 alone, before opening a single additional application, already consumes close to 6 gigabytes on an 8 gigabyte system. 16 gigabytes provides considerably more genuine headroom for actual multitasking, running multiple applications and browser tabs simultaneously, and accommodating the kind of ongoing software updates that tend to gradually increase an operating system's baseline resource requirements over time, even as Microsoft continues working to reduce that same baseline footprint through the optimization efforts already underway. There's a broader, genuinely important lesson embedded in this entire story, one that extends well beyond just this single delivery optimization setting specifically, and it's worth articulating directly because it applies to how anyone might think about diagnosing and addressing performance problems on their own computer going forward. Modern operating systems, Windows 11 very much included, run a substantial number of background processes and services that most users never directly interact with, configure, or even know exist by name. And periodically, some of these background processes turn out to consume considerably more system resources than most users would reasonably expect, or than the actual practical benefit they provide genuinely justifies for that specific user's particular situation. Identifying and understanding these kinds of issues typically requires either genuinely detailed personal technical investigation, actually digging through Task Manager's process list and researching unfamiliar process names one by one, or relying on the kind of dedicated technology journalism and enthusiast research that specifically focuses on uncovering and documenting exactly these sorts of less obvious, less publicized performance issues before they become widely understood by the general public. This is precisely why staying reasonably informed about ongoing coverage of your specific operating system's known performance, quirks, and issues, even in a fairly casual, general interest way, can provide genuine practical value over time, considerably beyond just this one specific delivery optimization example. Windows 11, like essentially any complex piece of modern software running on an enormous, incredibly diverse range of different hardware configurations, will likely continue to have similar issues surface periodically going forward, background services or specific system behaviors that turn out to consume more resources than expected on certain hardware configurations, sometimes introduced or altered through routine system updates that weren't specifically designed with this kind of unintended resource consumption in mind. Understanding the basic pattern here, that background services exist, that some are more genuinely necessary and beneficial than others depending on your own specific situation, and that periodically checking on and understanding what's actually running on your own machine can meaningfully improve its performance, represents a genuinely useful, transferable piece of practical technical literacy, considerably more valuable in the long run than simply memorizing this one specific fix in isolation. So, to bring this back around to the practical, immediate question at the center of this entire story, should you actually go turn off delivery optimization on your own Windows 11 machine right now? For the overwhelming majority of individual home users, particularly anyone running a machine with only 8 gigabytes of RAM, or anyone who's noticed their computer feeling increasingly sluggish without an obvious explanation, the honest answer is genuinely yes. This represents a safe, easily reversible change, one that won't damage your system or prevent Windows updates from installing, and one that can provide a meaningful improvement in available system memory, particularly valuable on the kind of lower spec hardware where every additional gigabyte of headroom tends to translate into a noticeably more responsive everyday computing experience. If you specifically manage multiple Windows machines within a larger shared network environment, a small office, a household with several devices that do tend to update in reasonably close synchronization with each other, the calculation shifts somewhat, and you may find genuine practical value in keeping delivery optimization enabled specifically to take advantage of the bandwidth savings it's actually designed to provide in exactly that kind of context. What makes this story genuinely worth understanding, beyond just the immediate practical fix itself, is what it reveals about the honest, complicated reality of modern software development at the scale Microsoft operates at. Windows 11 runs on an almost unimaginably diverse range of hardware, from brand new, high-end machines with dozens of gigabytes of memory to considerably older, budget-oriented laptops that were never particularly powerful. To begin with, even when they were first purchased. Building a single operating system capable of running reasonably well across that entire spectrum of hardware, while simultaneously adding new features, new visual designs, and new underlying capabilities year after year, represents a genuinely difficult engineering challenge. One where trade-offs and unintended consequences, like a background service consuming more memory than most users would reasonably expect, or than its actual practical benefit justifies for a considerable portion of the user base, are likely to keep surfacing periodically, even as Microsoft continues working, by its own public admission, to address the broader pattern these individual issues collectively represent. For right now, though, the practical takeaway remains genuinely straightforward and immediately actionable. If your Windows 11 machine has been feeling sluggish, particularly if you're working with a lower spec system that doesn't have much RAM to spare, take a few minutes to check your delivery optimization settings and consider whether disabling the peer-to-peer sharing component makes sense given your own specific situation and how you actually use your computer day to day. It's a small, safe, easily reversible change, but on the right machine, in the right specific circumstances, it can provide a genuinely noticeable improvement, freeing up memory that's currently being consumed by a feature most users never explicitly chose to enable in the first place, quietly running in the background of a system that Microsoft itself has now publicly acknowledged still has a real meaningful room for improvement when it comes to how efficiently it manages the memory resources of the machines it runs on.